if we are efficient, we may cover the 2 chapters. So we'll talk about chapter 5, which is matching tools to tasks. And we will cover here, I think it's divided into 3 areas: metrics. I think the order was metrics, logs, metrics, tracing,
Logs
and logs.
and traces. You're right. Yeah.
Yeah.
Because that's the reason I started with this diagram right here, which is from the CNCF page. Like you always have diverse set of tools. How would I know what's my right tool, right? And I really wanted to focus on the tools. So curious, like if anyone here is using any of these tools, and and you have any opinions around, like why would I use Prometheus versus OpenTelemetry? Like any thoughts, comments before we talk about the different tools?
You can put it in the chat or you can say it. Um, One thing I will say that in this picture, I don't know if I click on it, it becomes bigger. Yeah, a little bit. Is not all of them are CNCF. I think this is a rant that I always do in my live streams. People think that the 33,000 projects in the CNCF landscapes are CNCF projects. Some of them are just private projects from vendors. It could be any type of project, but there's you can filter down to which ones are the CNCF. Not saying that which ones are bad, or not what good or bad. It's just they're different, right? So here there's CNCF. I didn't know which one was. I didn't know Cortex was CNCF. So Cortex is CNCF incubating, and then what stages there are: graduate staging, and then Thanos. That's the latest one that was got added in this list. Vikram,
So
Thanos.
is it graduated? I thought it was incubating. Maybe I'm wrong.
But yeah, if you go to the landscape webpage, you can filter by observability, and you get a list like this.
Yeah.
And
I
many
guess
more. I think
it
that
is still
that's
an
that's re-
incubating project. Mhm.
yeah. I think this is a very short list of tools in the observability space. I think there are more than that, but
There's
at
more.
least the ones that we're going to discuss in the book are the ones in this chapter, right?
So if I could comment, so there's just like our customers are like telling us what to do. Like our customers do Datadog,
Yep.
and and customers do what's another one like Datadog? Um,
Dynatrace
Dynatrace.
yes. And so the part of the
or Splunk. Yeah.
problem is whatever one we do, it's not what our customers want. So we have to do both. So we end up doing all. So the idea of OpenTelemetry is maybe we can do it once and it works for multiple customers.
Yep.
And so that's sort of my mindset on this, because they're all good and you pick one and they're fine, but it isn't just one.
Right.
It isn't just one. And so
S-
that's my
And
comment on this. That's my
and
comment.
No, that's
just for context, Jack is talking from a perspective of a software vendor, like an ISV or something, a
Right.
software vendor that is providing software that you give to a customer, and that customer runs this software in their Kubernetes cluster. So
Right.
that
I'm a
software needs to be
vendor
observed.
supplying. Yeah, I'm a vendor supplying,
Yeah.
and I have a ready-made Prometheus infrastructure, and I have a whole really powerful, I'll call it hand wave around OpenTelemetry.
Okay.
And the future is OpenTelemetry, and we are embracing that. And every one of our customers says, "Cool, we do Datadog." And it's okay. It's all good. It's all good. That's just the realities of this particular space, and interested to see how others are sorting it out.
Yeah. So one thing that I would like to bring to everyone's attention is that we spoke about how observability is a good balance between metrics, logs, and traces. So you'll have to define what signals you're collecting, and based on that, you don't want to run like multiple tools to like tools for metrics, tools for logs, and tools for traces. If there is like a mature standard tool that's out in the market and people use it, like I would say, like go for it. For instance, if you're looking at OpenTelemetry, it can pretty much do metrics and traces. Logs is, I think it just becomes stable. There are
Yep.
some beta plugins available, but still, if you have use cases like that require sophisticated level of processing, which is not yet supported by OpenTelemetry, that makes sense. And you have your own backend, and the backend provider sort of gives you the agent, that's a different story. But if you're someone who's just starting your journey into observability and you don't want to like spend too much time validating which is the right tool for you, I would say OpenTelemetry is pretty good when it comes to metrics traces, and if you can just double down with logs, then that's great. You are
Yeah.
just looking at one tool. Yes, there is a scaling challenge. You have to make sure that you provide adequate, enough sufficient resources to your agents. But that said, you're now dealing with one agent compared to having like multiple agents running on your Kubernetes cluster.
Yep. And so in this chapter, you just you are describing that, going over the different tools on what
Right.
they are. So then later we can talk about we pick pieces from each project. Like I could pick the protocol or the format from Prometheus, but not necessarily the collector, right? And then
Exactly.
so I think I saw, because I was a little bit confused on the next chapter was explaining OpenTelemetry, and everybody wants to jump to OpenTelemetry. And I think people get confused when they see that configuration OpenTelemetry about talking about other tools, and people say, well, is OpenTelemetry like a collection of all these projects into one? So I think it's a good thing that I think this chapter is a baseline, right? To people
Right.
understand like the baseline. So the first one is Prometheus, where I see in here in this one, this is a typical way. Maybe this is what you had to run if OpenTelemetry didn't exist at the time. OpenTelemetry didn't existed. Any other stuff existed. It was the standard stack that everybody had, right? Is that correct,
That is
Vikram?
correct.
Back then, right?
That's correct. Back then, Prometheus, like everyone knew just Prometheus, and Prometheus did metrics, and it did it in a great way. That's awesome. But there are like a lot of tools coming up. So I was like, for someone who's just getting to know about observability, opening it up, letting them know that these many tools exist, and these are the use cases for these tools, and then what would you want to select based on your use case, right? Like based on the observability signals that you collect and you monitor. And then we kind of slowly deep dive into OpenTelemetry, which is more or less becoming a standard platform
Yeah,
because, yeah,
it's a standard. Like that was the main reason it got created. And I think um, pretty much my perception is like all the vendors, all the users, agree and collaborated. Like this is a standard. We don't need
right.
another one. And the first thing that they tackle was metric for like almost more than a year, right? Just metrics, right?
Metrics, and I believe traces came after that.
Yeah.
One of the powerful thing with OpenTelemetry is that the SDKs are so like the ecosystem is very wide. For example, no matter what language you use to develop your applications, OpenTelemetry sort of gives you the SDK to instrument the apps, both auto instrumentation as well as manual instrumentation. Right? There are
And
like
maintain. They're well maintained. That was the
well
other problem I
maintained.
found with previously in the past. Right, we different projects had like all the
Ca-
languages and SDKs, but they were not well
Yeah,
maintained. Right.
Carlos, just to clarify, yeah, traces came first before metrics.
Traces.
Yeah,
Oh, really? Good
Yeah,
data
yeah,
point. Thank you.
traces.
We have a historian here. I only remember.
no,
I
I,
remember open census dilemma when I was working with in that standard with Google.
yeah, no, I can give you a little more history. Actually, traces came from open tracing, and then
Yep.
there's a bunch of other contributions. So traces was the first component that became GA. Metrics became GA about
Later.
2.5 years back. So yeah,
And then
Right.
logs now is GA or not yet?
logs are GA in pretty much all the pretty much every SDK has a log implementation. Some of them
Right.
are still made up, but there are a few like Java is already as
In
as
terms
a
of the application SDKs, but the collector, is
The
that stable?
collector logs are stable for certain exporters
yes.
like file
The, collector-
processors. There are like a
yeah,
couple of exporters that are stable, and then
yeah,
there is a list of again, these are all plugin based, so you can enable the plugins for each of the exporters. So for some of the
yeah,
exporters it's still in beta.
yeah.
Okay.
So yeah, so just to, just round it up. Logs receiver has been there. File log receiver has been there in the collector for a
Correct.
few years now. The
Like one, I think it was like last reinvent time around, like I think like around late last
yeah, yeah,
is
yeah,
when I think it went GA.
yeah. Yeah, so Hotel did not want to tackle logs because every language framework has its own logging. So they had like a plugin kind of concept in logging. So they were reusing whatever logs were coming out of the language SDKs or language frameworks, because like Java has a strong log4j, SLF4j, and so on, right? So similarly, other languages have it too. So now there is a events and the logs API also getting uh, formalized. It's actually more in the semantics side, right? But pretty much
Right.
every language instrumentation has logging capabilities today. And OTel collector, of course, had logging in the pipeline for some time now.
Okay. Thank you so much. So we're going to tackle open telemetry on chapter 6 deep dive, but at high level, this is you try to describe enough, and then you go into details before. So open telemetry collector, Vikram, it's the collector is it's a single container, right? That gets configured with this YAML that you see here, like receivers.
Yes.
Can you talk a little bit about like what this
So if
receiver
you, I
endpoint, gRPC and endpoint means? Like, is this like they're connecting to something or they're exposing that port? Like that maybe people confused about that piece.
yes. So, if you are thinking about the hotel collector, you would want to start with the architecture diagram, like the figure 5.3 I've added. So on the left, you have receivers. Receivers is how the hotel collector receives the signal from each of the endpoints, right? And then you have uh, extensions like processors. For example, let's say you are collecting some sensitive data, PII related data, and you would want to opaque those informations. That's where processors can be really helpful. Like you can filter some of them, you can batch them. Even if you're applying some kind of a sampling strategy, I remember I talked about sampling in the last meeting, if I'm not wrong. Like when you're collecting traces and logs, metrics, they can always be huge. But if you want to just confine to what you really care about, for example, I really care about 5xx and 4xx. I don't want 2xx. So I might apply selective sampling. For example, I might
To drop.
sample my
Yeah.
exactly to drop the signals, right? I might sample my 2xx more compared to the error status codes. And that's where the processor is very handy. There are like so many processors available. And especially when you're when you're running hotel collector in Kubernetes, there is a Kubernetes attribute processor. What it does is the metrics that it collects, the signals that it collects, it is going to enrich with all the Kubernetes metadata, like things like namespaces, pod, which we know is already existing. Like when you scrape the metrics, Kubernetes sort of provides these labels, but just imagine there are like additional level of metadata information that can be enriched along with the signals that the hotel is collecting, right? So
So
take a look at the processor. Go
I
ahead.
have a dumb question.
Sure.
So I have a dumb question. So maybe the only one allowed to make dumb questions. No. So the dumb question is you mentioned the receivers. So let's paint this out. So you have a container in a pod running the open telemetry collector.
Mhm.
And then I have my app, my Node.js app running in a different node in a container, and I'm exposing an endpoint slash metrics. We go with the
Exactly.
remember last week like slash metrics
Mhm.
on my
Slash.
Node.js application. I'm not sending my metrics to this receiver or this receiver going out to my Node.js container to do an HTTP call. I'm
Yes.
confused. Like it's receiving,
So
but
you
or
would
is it
define
scraping?
your OTLP endpoint in your applications, which will then be used by the collector to get the signals from. That's one way. That's the OTLP receiver way. What Hotel also supports is a Prometheus receiver. You can even have a Prometheus plugin enabled. Whatever the scrape config that we have, like you define the target endpoints, this is my port, this is my path for metrics. That works. That's the beauty of Hotel Collector. It supports almost all the commonly used receivers. So it could be like a OTLP receiver, it could be a gRPC. So if you're using OTLP, gRPC, HTTP, you might have to define the targets. So the endpoint here refers to the local node or the pod or the service endpoint from where hotel can go scrape the information from. But if you are using Prometheus, you could go in a generic way, like how we configure Prometheus, right? Like you configure the service endpoints, or if you can just configure pod as the endpoints. Kubernetes out of the box gives you the metrics through these endpoints. You can simply define them in your hotel config and then collect signals.
So this HTTP endpoint in here in protocol OTLP, it means that it will go
That's
where
specific.
localhost 4318, but
Correct.
on which container? On my Node.js container? That was the
on
dumb question.
your Node.js container. So ideally, it would be like your own container, or in this case, it's the local address, right? So it goes scrapes the 4317 port, 4318 port. But ideally, you can also define your own Node.js application endpoint there, and it would go directly fetch the pod.
So
So
see why it's a dumb question, because I see 000. Like my Node.js is not sitting on 000. I
right,
have two pods, right? And one pod is the OpenTelemetry collector. The other pod is my Node.js app sitting at a different IP address. But
yeah.
we'll go deeper. I just wanted to ask that because it was maybe people, I had the confusion, right, of the 000.
Totally.
But you also explained
So
that their mechanism for OpenTelemetry collector and the controllers to dynamically find my pod, that I put information in a
exactly.
label. There's labels that I can say, hey, my Node.js app, I'm not listening / metrics, I'm listening / Carlos, and instead of port a
Then
4318 is port 8080, right? And I define that as a label, and discoverability, right? OpenTelemetry has some mechanism that I know the Prometheus way of doing it. OpenTelemetry will learn about it.
right.
So just for sake of time, let's continue on the next one. The next one is let's talk
Just
about.
wanted to add one point there, Carlos. Like to avoid the same confusion, I have defined, the code bundle that I've shared, the example that I walked through has the specific endpoints configured. So I show how you can instrument your applications using OTel SDKs, and in that particular
In
example, I would
chapter
have
7,
defined.
the example in chapter 7 with the instrument.
Yes,
Okay, good,
yes,
good
yeah,
point. So later in chapter 7, we'll talk actual example of doing that. So yeah, you go over in chapter 5 over the different tools. Cortex. I read this is a different tool like we saw at the beginning of like high availability
right.
and the but it uses the Prometheus format, right? That's the standard, right? On the wired, we're still using Prometheus. Is that
Right.
correct or not?
You're right. Yes.
Okay. And then
And we do a comparison as well, like where do we think like Cortex makes sense, and then where we think like Thanos might be a better candidate, like based on the scalability and the way we query, because Thanos kind of gives you this global query view, so you can literally run your queries across your backends and get the results back, and it also has some deduplication built natively into it. So if you're storing the metrics over a point of time, it gets compressed, deduplicated, so that way you're not spending a lot on storing these metrics over a point of time.
so this is a good observation, right? For people, I'll continue asking them questions on behalf of maybe other people
By the way,
that.
this is no
Uh,
dumb question. This
um,
is like a
so
valid question.
the other dumb question is, or maybe misconceptions, right? People may think that the open telemetry or this open telemetry pod that you deploy has a database, is the one in being a time series database, and it has all this information, and that's incorrect, right? Open telemetry, what we're talking about when you deploy open telemetry code, is a container of software that is a collector part of open telemetry. But to store the metrics, right, in a database, that's not open telemetry project. That will be the Prometheus
Right.
database with their API. And I see some people coming from that and using it in production, and that's okay. The next wave of end users that I talked to, and I remember I work in AWS as a solutions architect, the big other wave is Thanos. And for Cortex, to tell you the truth, I don't hear that much. I don't know if that's true. What do you think is that? Maybe I'm not talking to the right customers, or is that the progression? I see a group using Prometheus, and that's fine. I see another group like Thanos, and then Cortex. Not that much for people just running their applications in Kubernetes.
So you're asking like how I didn't get that question.
So it is
Carlos.
Cortex for a very small Cortex being used by a small set of end users that need that high
Adoption.
scalability, and it's very difficult to scale. And Thanos is easier, and that's why more people use Thanos than Cortex. That's just my point of view. And you can
Uh,
tell me incorrect, Carlos. More people use Cortex
I mean,
directly and download it
there is a
than
good
Prometheus and
there is a
Thanos.
good there is a good mix of folks that use both Cortex and Thanos, but Cortex is like to your point, it's scalable, and some of like I don't know like when you're talking about uh, how you can reliably durably store this information within Cortex, that's where it gives you a, an edge. And if you look at Cortex, like it supports various backends. You are allowed to configure the backends of your choice, and Cortex does the job of okay getting the signals and storing them in a way that it could be stored as a blob or like depending on whatever the storage you choose. But when it comes to Thanos, it's about the end user experience. Like how can I better run my queries across my Prometheus backends, Prometheus instances, and high availability. To your point, right? This is more scalable. Thanos is like more high availability because Prometheus itself is built as a lightweight tool. It doesn't guarantee any HAs. The moment you start doing HAs, you add complexity on top of Prometheus, and you would want to make sure that the data replication happens, things like that. And that's exactly what Thanos solves. So if you think about high availability, cost-effective storage, powerful ways to run your queries, probably Thanos. If you are looking at like long-term storage, highly scalable solutions, because you are handling like let's say 1 billion time series, active time series, things like that, high cardinality metrics, probably Cortex has a good, it gives you good, it kind of meets those needs.
Yeah, and just to end, there was a talk that I went to in Argo in KubeCon, Paris, and it was around like scalability of Cortex, and it was from our two of our peers that they're from the AWS managed Prometheus and managed Prometheus, right? It has the word Prometheus, but it's built on top of Cortex because
Cortex.
of the scalability and the
I,
need
I was
to
about
run
to
that.
say that, but I was hesitant whether we kind of share this publicly. But yeah, if it was discussed in KubeCon, yes, we built Amazon Prometheus on top of Cortex. So
Yeah,
that
and there's a few blog posts that talk about like 200 million active metrics and how we
yeah,
scale Cortex. It's open source, so we contribute to that.
yeah, 200 million active time series, and that's a soft limit. If you want to go beyond that, you can always reach out to the service team, and they can help you increase that limit as well. So scalable, highly scalable.
Yep. Okay. I think because a lot of people have. So moving on to any questions on metrics, at least for now, because we're going to deep into OpenTelemetry.
Yeah, I wanted to make ask a quick question because you guys were discussing a lot of this Thanos versus Cortex and
Yep.
metrics options and so on. And my question is, this is you guys are only talking about metrics, right? So
Metrics. Yeah.
yeah, when we talk about open telemetry instrumentation and collecting all this, we are not just talking about metrics, right? We are talking
Yep.
about traces and logs. So
Yep.
how do you do that in AWS, or what is your experience with other signals, and how do you correlate all of them, not just metrics?
I don't
So
understand the question.
So the question
Well,
is,
we were talking about Cortex and Thanos, and we
yeah,
should not compare those two to OpenTelemetry.
right. So my question is, when you do Cortex and Thanos, you're only doing metrics.
Yep.
And OpenTelemetry will have other signals. So how do you correlate the metrics that you're collecting in Cortex, Thanos, and AWS Prometheus Managed Service with other signals that are coming from OpenTelemetry instrumentation?
so that's where I think OpenTelemetry is really powerful. Like when you instrument the signals, it can even inject AWS metadata. Again, the instrumentation chapter that I talked about, I show how
Or in
you can.
general, cloud data because it's multi-cloud, right? It could be.
Yes,
Yep.
how you can inject those. For instance, if you are aware of what ARN is, there are ways by which you can even inject ARN informations into your observability signals. You don't want to have ARN per se, but then some of the metadata of your AWS resources can also be passed along when you instrument your applications, and that's going to be preserved. So finally, when you kind of visualize them in a centralized platform, these are your connecting dots, the metadata that you've instrumented your hotel with, are your connecting dots. That's one way you can do it. It requires some engineering efforts, but once you do it, you'll be able to see like everything, like no black boxes. You can see end-to-end flow of your signals from one microservice to other microservice. Does that make sense? It
Yeah,
needs
I think,
instrumentation,
yeah,
right?
yes. I was just trying to understand because you have to store all of this other signals as well, right, to correlate. And I was trying to
Right.
understand how you do it.
Exactly.
So I think we
Exactly.
can probably table it when you're getting into other signals.
Right. And I can also share an example where we literally enable the instrumentation using Hotel, and how we kind of visualize this finally with Grafana. Like all the signals can be kind of correlated there. But if you're looking at native monitoring, yeah, go for it, Carlos.
Yeah, the net is I think the correct of the question was like you would not have a single database with the logs, the metrics, and the tracing information, right? You will have 3 databases at the end of the day that
Or
they
maybe
will
two.
that the events will have correlated information and tagging, and then it's something that goes be above of those 3 databases that you can start doing queries, right? There's different solutions on correlating that, but the net is for people that are getting started. Like, you're not going to put your logs and your tracing and your metrics in a single database. There's purpose-based database. For example, OpenSearch optimized for putting the logs. Prometheus or Thanos, Prometheus Scanner Cortex optimized to put Prometheus metrics. So that was a good question. Thank you for asking that.
If we were doing a transition, could I ask too?
Go ahead.
Okay. For Vikram, do you see anything from vertical industries? And my particular one is the mobile network operators. The standards for how mobile phones work in 5G networks, there are hundreds of metrics to find. You know, the signal strength of each of the radios that are being received, how fast the device is moving, how many cell sites that they can see, and all these metrics are being collected in real time in a standardized way. And the question is anything from my field of mobile networks, is any of this spilled into the work that's visible to you, or is this a completely different layer on top of this? Because I'm as far as I know, my particular area has its own separate vertical and own separate way of solving it. I think we should be using this. And for all I know, we are already using it. And I was just wondering if any of that was visible to you.
Not really. I haven't come across anything specific on mobile telecom. Yeah,
mobile.
vertical. Yeah, but how are these, like, how are they running, Jack? Like, if you can ask, like, if you can talk about a high level.
How they're running? So a mobile device which is always moving, needs to maintain IP connectivity. Even though you're moving, you keep the same IP address. And it's very hard to do if you're constantly moving from cell site to cell site. And so you have to have different metrics to make a decision, be collecting metrics to make a decision on which cell site you should move to. So it's basically a time series metrics collection with weighted averages across the time series to help you decide where to switch to. And it has to work across vendors because there's different vendors for the mobile phones and different vendors for the network equipment. So there's a whole set of standards on it, and no one's going to tell 20 years worth of metrics to go redo yourself on top of OpenTelemetry. But I could imagine new work being done, like, although the 5G standalone stuff is all on Kubernetes, I could imagine somewhere in the telecom industry, someone's working on that. It's just where I sit, I just don't see it. And that's all. I was just looking to see if you had any visibility.
I mean, interesting use case. I haven't come across, but I think we should pursue this. Like, if you are doing something around this space, if you have some blogs or some work that you've done, would be interesting to see. And all of
but
these
not an hotel yet. Not an hotel.
But can the application be instrumented to emit this signal, like whatever you're talking about?
Oh yeah, it does. It emits it today. That's how the whole network works.
Hotel is just a vessel, right? Like, which collects the information and then sends it to different destination. But if the actual application itself, your mobile application, can transmit them and can transmit in a format that hotel can understand, which is now possible using the instrumentation libraries, then probably we can collect these signals and have them processed.
Let's stay with this because it may depend, right? Those signals may need to go in less than a millisecond, right? So auto may not be able
some of
to
them,
do those things.
Yes, indeed, some of them, Okay. And so if you're at a stadium and someone scores a goal and everyone starts sharing video at the same time, there's a whole bunch of metrics deciding how the network handles that kind of traffic.
Yeah, it's a network. Metrics are part of the network solution.
Yeah. Anyway, that's that. Thank you for the answer. Thank you for the discussion.
Let's move on based on time. Good insight of how metrics are actually used for running the applications, right? Part of the solution. So the next one is Fluent. You talk about Fluentd, um, and then Fluent Bit. Let's talk about the difference on those two. There's a little bit of table here. Who came first, Vikram?
If I'm not wrong, it was the Fluent D.
You got it right. It was a quiz.
Oh, oh, nice. So yeah,
Um,
so Fluentd is pretty good, comprehensive, has so many plugins. Like you see there, it is little memory intensive. So, we came up with Fluent Bit, which is less memory, less resource intensive, yet it can, perform much
high
faster.
performance. Yeah.
The only caveat would be like, if you compare both Fluentd and Fluent Bit, the plugins, like, it might not have all the plugins, but again, this is also something that is being like there is active contribution, very well matured project.
Yeah, Fluentd was very, very, very popular. Was kind of like the standard for many years. What I remember because of the plugin, like you were able to write a plugin with Ruby, like super easy. Um, and there were plugins for anything out there that you can imagine, right? But then I remember Fluent Bit. This was when I was doing work around serverless containers, and then research team came saying we have to switch to Fluent Bit, and then we did a little bit of work, and it didn't have that many supported plugins, but it had just the 2 or 3 that we needed, right? Just to collect logs from a container, and then that's it. Like collect and then do the and maybe drop, not collect everything or do the filtering, right? And I think in the book you have examples on how they get configured, uh,
Right.
which is oh, you don't have an example. I thought it was an example here somewhere. The
I
source, yeah.
talk about it in the logs chapter, if I'm not wrong,
Yeah, I
I
think
believe.
this is from Fluent. The Fluent Bit has a configuration of input and outputs and those type of things. So we'll talk
Right.
a little bit later.
The
And then
logic is the same, like, metrics, traces,
it's a
log,
pipeline,
like
right?
there's a pipeline. You have a receiver, which through which the signals enter, and then you can do some manipulations, clip them off, enrich them, enhance them, and then you go to the exporter and funnel them to different
Yeah.
destinations. So
And it depends where you're coming from in this DevOps or Kubernetes space, uh, right? Our vocabulary is not, it's not extensive. That we just, when people are in a room, right, a bunch of us, and they mention the word pipeline, half of the room would think about CI/CD pipelines, and the other half of the room would think about metrics pipeline and logs pipeline, right? Because it's just a lot in that context. But let's move into Jaeger. I remember Jaeger, and you have Zipkin here. Yeah, Jaeger and Zipkin. I remember I started learning Jaeger where with the book that I mentioned, right, the inventor of Jaeger and OpenTelemetry, and I love Jaeger, and then I learned how to take Jaeger supports Zipkin formats. You can convert them into Zipkin. So if people are sending you a Zipkin trace, you can still use the Jaeger tooling, the UI on those type of things. And then Zipkin was popular in other projects. So what's the take in these two, Jaeger and Zipkin?
I personally love Jaeger, because the backend that Jaeger supports, you get better performance, and to your point, you get this UI, Jaeger UI as well, the console, which is also pretty powerful. But Zipkin, I mean, again, Zipkin comes with its own instrumentation library, just like how Hotel is. So it's kind of like go hand in hand. End of the day, it all goes back to the comfort, and application teams, they are very much comfortable using Jaeger, and some might have already used Zipkin. It's pretty much the same, but because I've used, to your point, I've used Jaeger in the past. I really like, for example, it supports multiple packets like Cassandra, Elasticsearch, Kafka. Depending on what you use, you can always like slice and dice your backends, and it gives you a good UI as well, from where you can get insights.
Yeah,
That's very key for traces, like because traces are huge. You would want like a service map to be available. For example, if you are talking about X-ray, like it's an AWS monitoring service, it comes with its own service map feature where the traces can be visualized, and by clicking each of these spans, you can see like what's the latency like, what was the request duration like.
And I remember for Jaeger, when I learned it was the time that Istio came out, and Istio had a nice. Actually, this is one of the reasons
Kiali,
Istio is popular because of the user experience.
right?
They just didn't solve the hard problem about the networking and the mesh. There were folks involved, and I think it started. Yeah, it was in IBM and then other Google and other projects. But the thing that I remember was it had the user experience. It came with Kiali, it
Kiali,
came with Jaeger, and Sevi is an expert on Istio. She can talk about it. But I think that's also something that contributes for
absolutely.
Istio being adopted is that level of user experience, having the GUIs to actually visualize like Kiali and Jaeger UI. I think those are the things like it was very popular. And
Yeah.
at that time, Istio generated or augmented, right? Envoy augmented all this traffic with Zipkin. I remember spending a day figuring out why stuff was not working because they generated the traces, the spans uh, with Zipkin, but they were using Jaeger, right? But that shows you that Jaeger was able to support traces that are like configured in the wired as Zipkin. Go ahead, Savvy.
No, no, all good. I just would like to add on what you just said. The even it's not too far. I mean, that visual experience was so powerful within Istio package with the Kiali, and I think it just draw a lot of attention on Istio itself as well. That's what I
And
would
you got it
so
for
to say.
for free, right? You did a Helm
Yeah.
install, and then you open a
No, no.
URL, and then you see
It was.
it.
I think you could even just install it with Istio Cuddle or something. It was
Yeah, it's
just
just
like
CLI. That
that.
was
It
the
has its
Yeah,
own
CLI.
yeah,
CLI. But Istio is a
yeah.
different beast altogether. You're not just talking about observability when it comes to Istio. It's like intelligent traffic routing, circuit breaking,
Yeah, yeah,
retries. There's like so
True.
much it adds value. Yes, you are running a sidecar along with your application, but that said, you have ambient mesh and things like that, which removes the heavy lifting of running these sidecars. But the biggest advantage is like intelligent traffic routing, and out of the box, it gives you all this information like latency, request duration, things. So without even having to instrument your applications or
yeah.
have something like Jaeger running, you get this information out of the box from Istio mesh services. So that's one of the biggest advantage.
Yeah, and I think we talk about instrumentation, like you mentioned. One of the reasons, well, at least for me, when I was giving a lot of talks on Istio back then, um, the first advantage feature that you get benefit using Istio was the auto instrumentation and observability. Before you did routing,
Right.
before you did mutual TLS,
Exactly.
before all that, people just had microservices and they didn't know how they were connected, or they couldn't figure out why they were slow, or which connection was failing. Just the fact that you can actually see this, visualize this, and then you never touch the code. It was code given by this other team that wrote Java code 20 years ago, and it was just a binary, right? A WAR file. Just run it, and then you just
Exactly.
Envoy goes like, well, there's an HTTP coming in and HTTP coming out. I guess I'll put tracing, right? What you have to
Exactly.
forward, the only thing you have to go forward, but you don't have to modify that much.
Yeah, for sure.
So I think that's it for this type of things. I think it concludes selecting the right tool, where
Yeah. So
it's a
selecting
scorecard, right?
exactly, it's kind of a scorecard. Selecting the tool kind of, when if you can go to the next page, Carlos. Yeah, those are different criterias. Like, do you have, maybe go to the previous page. That's a good one that you highlighted. I really wanted to talk about that. So when you're selecting the tool, it's always about what kind of workload you run, right? Like if it's like all Kubernetes specific and all the metrics are available, you just have to choose the tool that plays well with that particular compute platform. And then ease of consumption, ease of operation. Sometimes I might not have a full-blown team that can take care of instrumenting, collecting the signals, deriving insights. So on those cases, you might want to have like a managed solution where you spend less time on setting up the environment, but get the insights off the bat. Like if you are using a cloud provider, go with that managed solution. And then comes the scalability, right? Like you'll have to, again, when it comes to scalability, my best bet would be like going with the managed solution, because you don't have to deal with scaling your environment, backend environment. Rather, your provider will take care of that. So if you go to the next page there, Carlos. So
Yeah,
I
talking
think,
about
Mhm.
the service, right? The hard thing to do, like, are you going to manage? Are you going to run a time series database by yourself, right? Managed service. So we're not talking about the agent. The agent is the open source open telemetry collector, right?
Mhm. Mhm. Exactly, exactly. So select your signals, select your platform, and see the operation model is like you need more visibility. You want to customize your observability environment, or is it just ease of operation? I don't care about like observability model. I've already enabled all my key performance indicators in my application. I just want to consume them in a good way without having to spend most of the time. So that's how we kind of, those are some of the criteria. There's also a talk we did in one of the reinvent, especially around this point. So if anyone is interested, maybe I can share the link this meeting or the next meeting.
Yeah, we can. You can put it in Slack, and you can also put it in the agenda.
Oh yeah, that's a
Put
good
it in the
idea.
agenda. I think that we're collecting all the links and all the information there. But this was, I think, is while I was reading the book. After I read the next book, like, I was saying, like, well, is the only, he didn't cover hotel. I was like disappointed because it was coming the other one. But at least you gave a baseline of choosing the tools, giving the options, and these are the typical. And also comes, you don't say it, but I can see it. Right, comes from our experience working with people running in production. We work in a
Right.
managed cloud provider. We work with a lot of customers in Kubernetes running at scale, and basically this is the type of stack that they pick, right? Open telemetry, Fluent Bit, in terms of collecting traces, and then Fluent Bit for logs. That's what I see today, but I think eventually people will just move to open telemetry for logs. And talking about open telemetry, and that's a good thing, because we learned that open telemetry is about the SDKs, helper to instrument, and the collection, right? Not the
Collection.
heavy lifting of holding and receiving all that information, right? Those are
Yeah.
a different aspect of it.
And gives you a wide range of SDKs, like depending on the program that you use to build your application. And this was what I was explaining to Jack earlier, right? Within a click of a few seconds, you would want to collect these signals. What's cool with this is like a high level architecture of the SDK. It's just the instrumentation piece I'm talking about. You have the application code there, and with that, you can just enable the OpenTelemetry API and SDK, which gives you all the necessary APIs. Like if you are talking about metrics, it has a meter provider. If you're talking about traces, there is a tracer provider. So all of them are available as APIs. You just have to introduce them into your application code. And then the OpenTelemetry extension processing is also available within SDKs. What's also even more best is that it also has an in-process exporter. So if you don't want to deal with sending the signals to a collector and then shipping it to a different destination, you even have the option of exporting these signals right from the app, like right when it instruments, right when it generates the signal. Yes, it adds a overhead on your application, but for time sensitive applications like the one Jack mentioned, we can even explore this in process exporter. What's also good is that all of these are available as part of your auto instrumentation agents. If you want to do manual instrumentation, that's also totally fine. You also have the option of manual instrumentation. And finally, what are the signals that emits? This is like the ideal workflow. The second, where it says outside application process, where you have the collector, which has a pipeline, which has a receiver and exporter, and then finally you ship them to a durable service. This is like more a high level architecture of the SDK.
And can you talk a little bit about the auto instrumentation versus the manual instrumentation? Is that the same for every language? Is it a little bit different for all the languages? Um, is it like a little bit of or do you have a section on that here, or?
I have an example, like in the instrumentation chapter, I talk about both manual instrumentation, auto instrumentation, and talk about what the metrics generated by auto instrumentation. When it comes to manual instrumentation, what's cool is that I developed a die, like the roll die application, right? Like you roll a die and it generates some random number. So when you're calculating the number of times you rolled a 5, rolled a 6, rolled a 1, right? These are custom metrics. So you may have to play with manual instrumentation. You have to make sure that these counts, like I go to the code where you enable those counters for those rolls, right? That's exactly where manual instrumentation can be a great deal breaker, right? Like if you are having application which have very specific KPIs and you care about those KPIs, that translates to your applications, your organization's, let's say, revenue, then you have to spend some time manually instrumenting your applications, collecting those signals.
So what is
But
the auto covers?
auto
What type of
covers, like
things?
out of the box, like all, you can think of all the generic, request duration.
HTTP requests, error
Exactly,
response,
exactly.
incoming easy things to either you're
Applications,
responding when an error
right,
or a verb
right.
is being coming in, right?
Many a
Instead of
times you are
HTTP.
better with the auto instrumentation, but when it goes very sophisticated and
Yeah.
when you care about those KPIs, that's when you
So that's
spend.
metrics. Is it? It's
It applies for
another
metrics and
another dumb
traces.
question. Traces. Like, what is the difference between tracing traces auto versus manual? There's
Pretty
auto
much,
for traces.
pretty much the same, right? So when you say, there was a good question about correlation, how can I pass on the informations to
That's
different
why I asked him.
endpoints,
Yeah.
right? So when you define the trace, when you are defining the traces, you can enable using auto instrumentation. There is a thing called service name, service dot name. So each functions has a particular name, and when you enable the tracing using, like manual instrumentation, you can pass these service names. And let's say all the 10 different microservices that handle the request also has that particular metadata. So all of these signals, trace signals, is going to contain that metadata. End of the day, when you are visualizing this from a service map, you just apply the filter. Service name is X, Y, Z. You see the whole connectivity from first microservice to second microservice to third microservice. So you can go that that deep. So that's my point here. Like, you have to spend some time, but it's worth it. Like the time you spend, end of the day, when you visualize these signals through a interface or a GUI, you're going to see all the value for the time that you spent on
And
instrumenting them through that.
and this goes along with a book. I remember was is it the SRE book from Google? That's the name. I don't remember if that's the name or not. But the SRE book of from Google was around like the definition of it. The definition of SRE came from that book. It was written a long time ago, but I remember reading it in the terms of like what an SRE does in a platform team or a DevOps team. And I remember from the book that it was an SRE person. It's not a support person, right, that just handles incidents. An SRE person is someone that knows Go or
Yep.
Java or Node.js, right? It knows that's the language of what the application team is doing. And it's the one that read Vikram's book, and he knows what is tracing and what is instrumenting the app and what are the changes that we have to put in the app. Like we need to put this log provider and we have to put this metric provider and we need to do manual instrumentation because we want to have a trace that has a span that measures, because this microservice connects to a database and it calls an API and then calls a downstream microservice. I'm just giving a real example. I need to know which of those steps during the transaction was the slowest one and is
Right.
causing problems. So I need to go back to the application team and say, hey, let's sit down for a few days. If you don't know what this space is, I'm going to help you out. Give me the source code. We'll do it together. I'll submit the PR. You review it.
Right.
And then by next week, your app will be instrumented. And that's the SRE role, or one of the functions of an SRE. When I remember reading that book, is that makes sense, Savvy? Like you're a manager. Like what do you do? What do you tell people to do
Read the
all day
book from
long?
Google. That's just a great grasp. But I wanted to also share. You missed Srikant's question, I think.
Oh, go ahead.
Carlos, did you see? Might be a lame question, but a matrix that marries cloud versus tools industry adoption will give a great insight. Cloud native versus cloud favorite. Just to be mindful of the time, I really wanted to read this one for you guys.
Yeah, that'd be good. But again, this is something that the cloud
Cloud
provider
versus
has the
tools.
information, right? Like it's really difficult to pull this. Like for example, if you're talking about a CNCF tool, you can see the adoption. Like you can see the commits, how frequently things are committed, the number of issues open against each of these tools. But when it comes to the cloud provider and the tools adoption, I think it's a little tricky. What do you think, Carlos?
Yeah, this question I think is a trap. I like the Star Wars thing that it's a trap. Like when they ask that type of questions, like you have to pick which is the best thing to do. I at least in the space that I work, and I think also we work with a lot of cloud consumers, cloud customers, and they're just using our cloud, right? So we're not choosing. and then they come in saying they want to use CNCF tools. They want to use Istio. They want to use OpenTelemetry. They want to use Argo. So me and Vikram, we are in a group that we help them take advantage of these tools the best way possible and run them at scale, like run it in our servers and EC2. Like that's the end of the story. Like we're not choosing, they are choosing to run CNCF tools because they're running these applications also in other clouds and on premise.
Exactly.
So choosing, that's why I said like the tool, I think the customers that are using Kubernetes usually pick open source tooling. And some of that tooling we support, like OpenTelemetry standard that we're supporting, and if you have issues, you can open an incident, and it will work out with you. And then we work on like supporting that standard, the open source project, OpenTelemetry, that you can send those metrics to our managed Prometheus, right? We make sure that it's tested. So I don't know where the comes through, but that's the insight that we see. Like people that tend to use Kubernetes tend to pick a open source standard and tool, but they want to run it at scale. So then they will work with the cloud provider to see if they can